Let's look at the third problem on the study guide. Identify if the following numbers are prime or composite. Demonstrate evidence of your rigorous process to determine this result. So not only do we have to determine if it's prime, but we must show how we did this. So to do this, we must test all the primes for which the square of that number is less than the square of that prime. So I'm going to write down all of the primes up to 20. 2, 3, 5, 7, 11, 13, 17, 19. Now I want to write down the squares of those numbers. So 2 times 2 is 4. 3 times 3 is 9. 5 times 5 is 25. 7 times 7 is 49. 11 times 11 is 121. 13 times 13 is 169. And I'm already noticing that all of the numbers are smaller than this, so I don't even need to worry about 17 or 19 right now. So looking at this list, this will help me decide what primes I need to test. Our first number is 71. So if I look at the list, 71 falls right here, in between 7 and 11. So I only need to test the primes up to 11. So I need to test if 71 is divisible by 2, if 71 is divisible by 3, if 71 is divisible by 5, and if 71 is divisible by 7. For 2, it is not divisible because this ends in a 1. It is an odd number. For 3, let's see. Let's use our divisibility rule. We can take the sum of the digits. 7 plus 1 is 8, and 8 is not divisible by 3. I notice that 71 ends in a 1, so it is not divisible by 5. It ends in a 1, so it's not divisible. For 71, I either need to use multiplication facts or long division. In this case, I can use multiplication facts. 7 times 10 is 70. 7 times 11 is 77. So it's clear there is no multiplication fact in between using an integer. So we can say X there. So this is not prime. All right. For 167, it looks right here, that number falls in between 121 and 169. So this time I need to test the primes up to 11. So 167 divided by 2, 167 divided by 3, 167 divided by 5, 167 divided by 7, 167 divided by 11. We know that this first one fails because it's odd. It's an odd number. So we know that this fails. For our second one, we can use the sum of the digits. That's 14. 14 is not divisible by 3. 167 ends in 0 or 5. It does not, so I can put an X there. For 167 divided by 7 and 11, my best chance is likely long division, though you may know a trick for these numbers. If you do know a trick and you can show the work for it, it is allowed on the quiz as work. All right. 7 goes into 16 2 times. 14, bring down the 7. 7 goes into 27 3 times. That's 21. 6, that's a remainder. If there's a remainder, then doesn't work. All right, let's try 11. 11 goes into 167. 1 time there for 16. 5 times here for 55. 2 left over, there's a remainder, so it does not work. So I tested these with long division. So it looks like, again, this is not prime. Now for this next problem right here, it looks like you need to test up to 7 again. But you may notice immediately that 54 divided by 2 works out. 54 is an even number, so we do not need to test any more than that. Once a number fails, we don't need to continue. So not Oh, oops, I made an error. Let me erase that. These are prime. My brain saw the red symbol and thought not, but that's not true. If it fails all the tests, it's prime. If it passes the test, it's not prime. All right. Let's see the last problem here, 117. For 117, it looks like that falls right here in between 7 and 11 again, so I need to test up to 7. 117 divided by 2, that fails. 7 is an odd number. All right, let's show my next test. 117 divided by 3. Let's take the sum of the digits. 1 plus 1 plus 7 is 9. That is divisible by 3. I can stop here. My number has already failed to prove that it's prime, so I can say it's not prime. And we're done.